IoT describes physical objects or groups of such objects that are embedded with sensor, ability, software, and other technologies.
Welcome to the revolution.
Our vision is to enhance the emotional experience of everyone we touch. Our mission is to weave software and hardware into best-in-class solutions that ensure the enduring growth of our clients. At Zone24x7, we are committed to support our Fortune 1000 clientele, design the future in retail and high-tech industries. Our passion is fueling inspiration and enriching the lives of the people we meet throughout our journey from our expertise in engineering.
We at Zone24x7 provide the best of the breed technologies to our clients. Our DNA within our organization is to provide disruptive technologies which will change the way our clients perform and thereby making them highly successful. Most important, all these solutions we try to deliver on time and on budget. Our solutions come from throughout the world. We tend to bridge the relationships within Silicon Valley and the rest of the world, whereby we use our talent pool in Sri Lanka as well as our partner technology companies throughout the world.
Hello and welcome to the second webinar of InnovMind workshop series organized by IEEE Industrial Application Society of Sri Lankan Technological Campus. Today's webinar is all about product designing process and prototyping. This workshop series is powered by Zone24x7 and we hope you will get the best from our guest speakers from Zone24x7. I am Kasun Kavishka, one of the moderators for today's event. Before we jump into today's event, my colleague Santa will explain what we did in the previous sessions. So over to you, Santa.
Thank you, Kasun. Good evening, everyone. I'm Shanta Vijayasinghe, and I'll be moderating this event with Kasun. So first, let me tell you about IES and the project InnovMind. IEEE Industrial Application Society, IES, is a chapter of IEEE and is a world leader in the advancement of science and technology. IEEE Industrial Application Society of SLTC gives you the access to connect and collaborate with the professionals of the industry and to join valuable national and international projects. InnovMind, the InnovMind is a project organized by the Industrial Application Society of SLTC on the field of Internet of Things. The project started with an introductory webinar conducted by Mr. Thiline Apabandara on the 18th of September. InnovMind workshop series started on the 19th September with Mr. Ushan Shaminder, founder CEO of Rational Solutions, conducting a resourceful session on IoT hardware. If you missed any of those sessions, I highly recommend you to watch these at your leisure. You will find them in our social media platforms. Also, you can use the QR code displayed on the screen to go to our Facebook page. You will find the latest updates and the last sessions there. So, Kasun.
Thank you, Santa. Before me moving any further, I would like to explain functionalities of today's webinar. This will be broadcast live via Facebook and YouTube and our social media channels. We will be hosting live Q&A sessions to answer your all questions. So make sure to drop in your all question and comment in our Pigeonhole platform throughout the webinar. You will find the link on the chat. Without wasting much time, I would like to invite Manu Rajpaksha, the project co-chairman of InnovMind. So over to you, Manu.
Thank you, Kasun. Hope I'm audible. Hello, everyone. A very good evening. Hope you are staying safe and healthy and enjoying the weekend. As the co-chairman of the project InnovMind, I would like to warmly welcome you all to this second day of InnovMind workshop series. I welcome you all joining us today via Zoom, Facebook, and YouTube live, and especially all our participants from overseas who have been there with us since the beginning of InnovMind. I warmly welcome our guest speakers for today's session, Mr. Ranjan Kulathunga and Mr. Niroshan Karunaratne, who have dedicated their valuable time to share their knowledge and experiences with you.
Recording in progress.
Social media to get the latest updates on the competition. And so now let's focus on today's session, and I hope you all will enjoy it. Thank you very much. Over to you, Kasun and Shanta.
Thank you very much, Manula. Now I think it's about the right time I introduced our first guest speaker for today's webinar. So he's a very special guest. He's an experienced professional in hardware design, firmware design, and project development. He's a senior tech lead in embedded systems at Zone24x7. Please welcome Mr. Niroshan Karunaratne, senior tech lead at Zone24x7, to address the gathering. Over to you, sir.
Thank you, Sahanta. Hope I'm audible and you can see my screen.
Yes, sir, you're audible.
Okay, so good evening, everybody, and hope you all are having a wonderful evening. So today we are going to discuss a little bit about product development. So we all use different products to make our life easier day in and day out. But sometimes when we try to use some products, we can't help but think who in the world had designed these. Right? So some of these product failures are very obvious, but sometimes they are like not that obvious, right? But still they should have like these kind of issues. They should have fixed this and corrected them before they entered the market. So in today's session, we will be discussing about this product design and development actually in two parts. First, we will discuss the overall process that we need to follow to successfully develop a product and avoid these failures which I showed previously. So we will first of all see some of the challenges which is involved with product development, and also we'll go through some of the design phases which is involved in product development, and also we'll discuss a little bit about product testing and product certification process. And as the second part, so my dear colleague Ranjan would explain to you all, like as engineers, what we need to do to make sure that our product product would be successful at final, right? So let's start the session. So when we attend exhibitions and university project presentations, we see a lot of demonstrations like this. We see automatic street lighting switches and automatic plant watering systems and mobile phone controlled home automation systems. We see a lot of ideas like this, which can be used to create new products. But we rarely see these kind of ideas being productized and coming into the market. So why is this? Actually, there are many reasons for this. For instance, so in product development, there is this concept called valley of death. So normally the goal of developing a product is to like sell it and gain some profit. But to develop a product, you need to first spend some money. So this graph shows the cash flow during different stages of this of developing a product. Right? So let's go through each stage and see how each stage would affect this cash flow. So first of all, you will need to have an idea to develop your product on. Right? So just having the idea itself is not sufficient. Right? So you will have to first of all check if the idea is actually a solution to the problem you are trying to solve. And then you'll have to check if your idea is feasible and if it's practically possible to be implemented. So there are like many things which work very well in theory, but not that well in practice. So after you have a solid idea, then you need a way to present that idea to other people, like investors and business partners or manufacturers. So you need to present your idea, which is in your head. You need to present that to other people. Right? So for that, you will need to create a prototype. So this prototype should represent your final product. Using that prototype, you can explain your idea to other people. So to create this prototype also, you will have to spend some money to get it created. Right? So once you have the prototype, you cannot sell a prototype. Right? So you will need to bring that prototype up to a manufacturable product. Right? For that, so to come up with a successful product, actually there is this design validation process. Right? So here we have several steps we need to follow. So we name them as EVT, DVT, Pvt. Right? So as engineers, we very much love abbreviations. Right? So we'll discuss about these stages later in the presentation. But the thing is, for all of these steps, you will need to spend some money to like successfully complete each of these steps. You need to spend some money. So once you go through this validation process only, you would be having a product that you could manufacture in large numbers. We call that bulk production. Right? So in the bulk production stage also, you have to spend a lot of money to obtain the materials and to obtain the components. And also you will have to pay the factory and the workers. So there are a lot of steps involved during this stage where you have to spend money. And after that only, you will be able to launch your product and start selling. So up to now, all of these stages, it costs money. So after you launch your product and start selling only, you would be able to earn money from your product. So if your product sells very well, then you would be able to recover your investment and make a profit. But about the reality is about 95% of prototypes which enters this valley, 95% of these prototypes would actually fail within some stage of this process. So they actually are not able to come out of this valley and they die within this valley. So that's why we call this valley of death. So this was only about taking into account the cash flow. Right? So to get a basic prototype to a production level that can be manufactured, there are many other hurdles we need to overcome. Also, this is not something that you can do by yourself. So the first part, like converting an idea into a prototype, so maybe that part you would be able to do by yourself. So most probably you would have the knowledge, or at least you would know how to obtain the knowledge to create a prototype, or at best you would know someone who has the knowledge which who can help you. Right? But when we go to move from a prototype stage, move forward from that stage, then only we face a lot of issues. So because here you will have to involve a lot of other parties, right? Like you need to involve manufacturers, distributors, and even government authorities at this stage, right? So in order to succeed, right, you will need to have a good idea of different hurdles you will have to face during these stages. And from our experience, what we have learned is that you actually need to know about these hurdles even before you start designing your product. So if you think I'll face them when they comes up, and you will learn during this process, then there's a high chance that your product would be very costly, and there's a very high chance that your product would fail. So the thing is, knowing this information before you start is very important. But the thing is, this information regarding how to practically get a prototype into a product level, it's actually very hard to come about this get this information. So the best way to learn this is to get this information someone who has already gone through this process. So as our company is Zone24x7, so we also have gone through this process several times. And so today I thought of taking one of the products we had developed as an example and use that example to explain these concepts using that example. So this is the product which I thought of taking. So the name of this product is Next Generation Price Verification Unit, NGPVU. I know it's a mouthful. So normally we go by its code name Q or X1. Right? So basically, this product is actually a price checker. Right? We can call it as a smart price checker. Right? So in Sri Lanka, normally, if we take some items, the price of that item would be displayed in the item itself. But in US and many other countries, in many of the products, the price is directly not displayed, but a barcode is displayed instead. Right? So you can take that item to a price checker and scan the item. So then the price checker would use that barcode and get the price from a database and display it to the customer. Right? So there are a lot of advantages of using this method. Right? So basically the Cube is such price checker. Right? And also we have added some extra capabilities into this price checker. Right? So let's see what they are. Right? So actually when we start this project, So when we start developing, our business analysis team and our sales team, they had actually done some research and some market studies, and they came up with a set of requirements for this product. So all we had to do is like come up with a device which would meet these requirements. Right? But if you are going to develop your own idea into a product, then you will need to do this research before you start developing. This is very important because you need to know that you could actually develop your product and you could actually sell it and at least recover the cost, right? And you need to know that before you start the initial stage itself, right? So actually there are companies who would be doing this research on behalf of you, right? So fortunately for us, we had this research was done for us already, right? So the basic requirement which business analysis team came up with is like this device should be able to like scan the barcodes and display the price of each product. Right? So for that, we actually used a barcode reader and incorporated that into our device. Right? And then they wanted to use this device so that the customers can actually call a store associate and get their issues resolved. Right? So for that, we actually added cameras and speakers, right? And by that, we allowed the customer to actually call a store associate using a video chat and then resolve their issues. And other thing is the device they needed to be able to like scan multiple items at once, right? So many of those items which they were selling in their stores, they had this RFID tags, right? So you might be familiar with RFID, which are available in these clothes and books and all, right? So these these items also have RFID tags, and they wanted to be able to scan multiple items at once. So for that, we added a RFID reader into our device. So the idea was the customer can put all the items which he purchased into a cart and bring the cart near the device. And then the device would actually scan the entire cart and display all the items and the item prices. And it would do the calculation and display the final amount. And the customer can pay the final amount and take the items. So that was the basic idea. Right? And then there were other requirements, like they needed to like capture the customer spending habits and those kind of things. So for that, we added IoT related capabilities for this device also. And also they needed for this device to stand out in the store, right? So like in this shopping malls and all, so they would like fix this device. So then the customer should be able to like take the product and come near the device and scan the device. So the customer needed to like see this device at the first glance, right? So initially we thought of like using a big display. So by using a big display, we can display all the. So we thought of going with a big display, but actually our team had done some research, and what they had found out was like people actually don't like to like use a big display to scan their products, because when you use a big display, the other people, the bystanders can actually see what this person is purchasing. So they thought it was like as a privacy issue. So they actually did not want to have a big display. Right? So that's why I said like these market research and all are very important, because these are like counterintuitive. Like we would not think like that at first glance, right? So because we did that market research, we knew like, okay, we cannot go with a big display. We would need to go with a smaller display, and to like capture the customer's attention. So we thought of using a light strip around the device. So when the device is idle, we can like display different light patterns. So then the customer would like see the device at first glance. Right? So like when this marketing team and sales teams come up with these requirements, so it seems to be like a battle between the sales team and the engineering team. Like sales team says we need this feature, and the engineering team says we cannot provide this data. So it's kind of a battle, right? But in product development, we actually need to work together since both aspects of this is very important, right? So because if you cannot market your product, right? If you don't have the features to market your product, then you will not get the funding you need to develop the product in the first place. And if you cannot develop the product, then you certainly cannot market the product, right? So both aspects of this are very important. So let's see what kind of things we had done and what kind of steps we followed to create this product which meets these requirements. Right? So here I took this example because this was this is an electronic device with some complex features. Right? So using this complex device, I'll explain these steps we need to follow. So if you are like developing a small device, so all of these steps would not be involved. You will not be involved in all of these steps, but it's good to know all of the steps. Right. So when we are developing a product, we need to go through this product development life cycle. So if we go through this product development life cycle, there we can, like with a high assurance, make sure that our product would not fail in the market. Right? So as we discussed, so the first step is to come up with an idea which you can produce, right? So based on that idea, then you can create a POC, right? So we call that a proof of concept, right? For this, you can actually use off-the-shelf components like Arduinos, Raspberry Pis, and other ready-made modules like single board computers and those kind of things. So you can purchase them and connect them together and show that your concept is working and your concept is correct. So the idea here is like to quickly come up with a device which you can present to other people demonstrating your idea. So here we need to do this quickly. So if the POC fails, we don't need to spend time much on this idea further, right? So normally we would create about 2 or 3 proof of concept units, right? And if the POC is successful, then we can move to the EVT stage. So EVT is engineering validation test, right? So here, because this because our product is electronic product, right? So this EVT stage is very important. Right? So I mentioned, like now in the POC we used off-the-shelf components like development kits and single board computers, those kind of things, right? But in EVT, you actually need to get them get them into your custom PCB. So you know, like on a product, you cannot use these Raspberry Pis and Arduinos and those kind of things, right? If you try to do that, it would be very expensive and it would not be very reliable also, right? So because of that, you need to create your custom PCBs and custom modules, right? So normally when you have IC or something on the development kit, it works very well, right? But when you take that component onto your custom PCB and incorporate other components, then many issues can arise. So there can be heating issues, noise issues, and power supply issues, lot of issues like that, right? So here we need to like somehow resolve all this and get all the components working on the EVT stage, right? So if like in this stage, like you will have to like create several iterations of this EVT stage. So for instance, if you create one EVT device, right? So sometimes in that there might be a power supply issue, right? So then you will have to like correct that and create another device like that. This is like within this EVT stage, there can be different stages like EVT1, EVT2, EVT3, like that. There can be a lot of different stages. So here the goal is to somehow get everything onto your custom boards and make sure that your hardware and software integration is working as expected, right? And so during this stage, we would be doing a lot of testing, right? So all of these testing normally would be internal testing. We would be testing how the circuit works, the power supplies, the noise levels, a lot of things like that. So we would be using, so here we would be creating about 10 to 50 devices, right? So we would be using these devices for different kinds of testing. So one is this internal testing, which I mentioned. And also we would be using this device for longevity testing. So that means we would keep this device switched on for long periods of time and see how the device performs, right? So sometimes some devices, like after 10 or 15 days, it would heat up and it would stop, right? So when we face those issues, we'll have to resolve them and again create a new EVT unit, right? So like that, we would use this device for longevity testing also. And also, like when you create products, so if you want to sell them in certain markets, so those markets, they require your product to have some certain certifications, right? So like FCC certificate, CE certificate. So we'll discuss them later in the presentation, right? But they require you to have these certificates. So there are third-party labs which actually provide this certificate. For that, we need to provide these units for those labs, right? So this process can be time-consuming and very expensive. So sometimes before we go to these FCC lab or CE labs, we go to pre-certification laboratories, right? So for those laboratories, we would normally provide this EVT unit, so for them to test it, right? So by doing these tests, so we can make sure that our product electronic wise, our product is working fine, right? So after we are satisfied with that testing, then we can move on to the DVT stage. So DVT is design verification stage, right? So here we need to make sure our final electrical and mechanical design, so that meets the functional requirements which is expected, right? Here we would develop about again 10 to 50. So these numbers depends, right? About 10 to 15 units, and we would be using these tests for external testing, right? So maybe we can send this for third-party quality assurance testing, right? And also we send this to the customer, or sometimes we put these devices in the field to test them. So sometimes we get issues when we put the device in the field, right? So to test that, we normally use this DVT units, right? So after we are satisfied with the DVT units, then we move to the Pvt stage, right? So Pvt means product verification test, right? So here we make sure that our product can be manufactured in a production line, right? So here, so up to the DVT stage, all this development was done maybe in-house, right? But the Pvt would be done in a manufacturing facility, right? So after we complete the Pvt stage, then only we can go for mass manufacturing, right? And although I have shown, this is shown as a single line where we follow one stage after that to the other stage, right? So this is actually not the case, right? So sometimes after the POC, we would go to the EVT, and after several iterations in the EVT unit would fail, right? So then if we cannot move forward, then we'll have to go back and again start from a new POC, right? So here, when you're starting this process, you must actually expect failure, right? So in this process, it's actually better to fail fast and learn quickly, rather than going forward with issues and finding big issues later in the future stages, right? So this can be like that. We can follow each of these steps and then create a final product, right? So let's see how we actually went through this process, right? So this is our initial proof of concept device, right? So as I mentioned, so you can see we have used single board computers, right, as the processing unit, and we have used a development kit. So this is the barcode development kit, right? So you can see the barcode part is only this part, but the development kit is large. So here the idea was to get these components off the shelf and connect them together and see how everything works, and to prove that our concept is correct. So this was for internal verification process only. So this is for for the engineering team to verify that everything is correct, right? And then after we are satisfied with this POC, then we would create a prototype, right? So the prototype actually should resemble your final product, right? So here I have shown only the internal parts, right? So even in the prototype, so we have like we have still used the a single board processing unit, because like to create a PCB which has a processing unit inside the PCB, that's time consuming. So rather than doing that, we still used the single board processing unit. And then like some of the other components, we have like incorporated everything into a single PCB. And then we have like connected everything, and we have like come up with a proof of prototype, which we could actually show to other parties, right? So this is only the internal part. So there was a separate enclosure and all for this, right? So after we are satisfied with the prototype, then we move to the EVT stage, right? So in EVT, so you can see like here now we have like replaced all of the single board computers with custom built PCBs, right? And also the wiring and all, these are all custom built wires, right? So like the lengths and all are like correct, and the connectors and all, those are like custom built for this device itself, right? So this we would be using to do different tests. So actually at this stage, you need to test each and every component to make sure everything is functioning as expected. So as I mentioned, like when we are like testing these, we will find different issues, right? And then we need to like resolve them. And sometimes we'll have to like create new EVT units. So this is a second EVT unit, right? So in this, like, so normally for like for the EVT unit, although we are just testing only electronic and software integration, sometimes we would need an enclosure to test certain components, right? So for example, like in our device, so I mentioned that we had a light pipe to grab the customer attention. So initially we had used this laser, LED laser, and a perspex pipe, which would go around this device, right? So like once we made the enclosure and tested this out, we figured out like, okay, this laser, the power of the LED laser is not sufficient. Like the light around the device was not uniform, and it was not very nice, right? So then at this stage, we were able to like replace this with a LED light strip. So to like identify those kind of issues, we actually needed an enclosure, right? And also like when you're like working with antennas, speakers, right? So the sound of the speaker, to test the sound of the speaker. So those kind of things, you actually need an enclosure. Without an enclosure, it's very difficult to test these kind of components, right? And buttons and the ports, those kind of things, right? So this enclosure actually does not need to be the final enclosure, right? So you can use like rapid prototyping techniques to create an enclosure for this, right? So you can use 3D printing or CNC to create enclosures for EVT units, right? And after the EVT unit was successful, then we moved to the DVT units, right? So here we actually test both the electrically wise and mechanical wise also we test, right? So normally, as I mentioned, this would be used for like third-party tests, right? So like during like the prototype and EVT stage, although we have like different tests, right? We have internal testing, and sometimes we use those devices for internal quality assurance testing also. But sometimes we can actually, there can be some scenarios which we actually miss, right? So what we notice is like, since we were like involved in this design, especially involved in the design of this device, and like because we were like people from the technical background, sometimes we actually know how to interact with devices, right? But when it comes to the general public, that's not the case, right? So for instance, I mentioned that on our device, the main purpose was for like to scan barcodes, right? So when we were testing the DVT device in-house, everything was working fine. right? But when we sent this device to the customer premises, and when they were testing it there, some customers were complaining that the barcode reader was not working. So when we like looked into it, what we noticed was like the customers were placing the barcodes right on top of this device, right? So normally when we are like scanning a barcode, we should leave a space between the barcode and the scanner, right? So like we knew that as technical people, we knew that, but many customers did not know that, and we cannot expect customers to know that, right? So we had to like quickly resolve that by creating this kind of space between the barcode reader and the item, right? So these kind of testing, so that's why this kind of testing is very important, right? So like if we had skipped this DVT stage and if we went for manufacturing and like created large amounts of devices and shipped it to the customer, then like the customer would start complaining, and we'll have to actually recall all of these devices and fix them, right? So that would be a very huge cost, right? So that's the cost is not only to fix the device, but we would have to pay for shipping and for storage and many other things, right? So rather than going in that costly way, we can actually, like if we follow this process, then we can find these issues before we go for mass manufacturing, right? And here, so like the enclosure part is very important, right? So for this also like, so enclosures are very expensive to manufacture, right? So for that, because of that, so here we can like use silicon molding technologies to create these enclosures, right? So like, so as I mentioned previously, like so we cannot expect to like test each and every scenario, right? So but if we like follow this process, so this process would ensure that we would like not create products which would fail in the market, as I showed at the beginning of the presentation, right? So right, so as we discussed, so in the DVT stage, we would be like we would definitely need an enclosure, right? So enclosures is like one of the most costly components in a product, right? So why I say that is like normally to create an enclosure, you would need injection molding techniques, some industrial technique like that. So for that, you will have to create molds, right? So molds are actually very expensive, right? And so how they reduce the cost is like using one mold, they create a lot of enclosures, right? So that's how they reduce the cost. But in this DVT stage, so you would not be creating a lot of enclosures. So that because of that, you cannot use these kind of technologies to create the enclosure, right? So we use like this silicon molding technologies and all to like create few enclosures, and we try to make the try to get everything correct regarding the enclosure. So then at the final stage, we can create one mold and we can like be sure that our enclosure design is correct, right? So we need to do all those testing. So or else like we would have these kind of issues where the things are not aligning properly. So all of these we can check during the DVT stage itself. So these kind of issues we can actually identify this during our using our prototype, this design software itself, right? So using the design software, we can actually see if everything is checking, everything is connecting properly, right? But there are some things we cannot identify from the design software itself. Like, so for instance, the colors, the color of the device and the texture. So these kind of things are
Yes, I think there's a technical difficulty. I apologize for the inconvenience.
Sorry for that. I think there is a power cut. Can you all hear me?
Yes, sir. We can hear you.
Okay, right. So let me continue. So hope you all can see my screen. Is it correct?
Yes. Yes, sir.
Okay, right. Right. So what I was discussing was like this the enclosure, like the colors and the texture, those kind of things are also very important, right? So these things you cannot identify that using the design software itself. So you need to actually have a unit manufactured, and then only you need to test this. So these colors and all, so selecting these colors, so these are a separate field, and it's a very important field. It's not exactly related to engineering, but very important, right? And the other thing is these buttons, right? So you need to like make sure, like when you're selecting these buttons and all, there's a very good feel to the button, right? So these kind of things are also very important, and these need to be done during the EVT and DVT stages. And regarding the speakers, so to check the speaker sound, so these like the patterns in this enclosure, those are also very important. And the light pipe, as I explained previously, right? And also the structural elements. So once we create our device, we don't want this to happen, right? So because of that, we need to like add structural elements, and so we can like use simulation softwares to test how we can add these structural elements, right? And there are like special techniques to like increase the strength of these structures, right? So once we go through all of these, then we can come to a Pvt stage. So in the Pvt stage, we can we are at this stage, we are pretty sure like we have like ironed out all of the issues, and we have a manufacturable product, right? So, but still to manufacture this, you need to go through this Pvt stage. So up to now, all of the development may be done in-house, right, in your facility, but the manufacturing would be done in a manufacturing facility, most probably in China or Taiwan, some country like that, right? So then you need to like make sure that a third-party person can actually manufacture your device, right? So for that, you need to like send some like design files, right? And also you need to come up with a process on how they can actually assemble the device and also test the device, right? So so this is like after we send our design, so sometimes we'll have to go to the manufacturing facility and work with them to create the pipe, the production line, and also like to give the testing procedures. Those kind of things will have to help when we are creating the final product, right? So here so I have shown our like final product and initial DVT unit. So you can see the initial DVT unit does not look anything like a final product, right? So this is because we had to go through several iterations, as I explained previously. So after going through, like after doing all of this, we were able to actually create the products and ship them out, right? So like even though we ship them out, still the process is not complete, right? So as I mentioned, like there's this industry compliance test we need to adhere to, right? So for instance, like there are some countries, right? Even like if you ship the components, if you do not have these certificates, they would not like clear these devices from the customs, right? So for instance, like FCC, right? So in the US and all, so if you do not have the FCC certification, then they would not allow you to clear the items into the country. right? So to obtain the FCC certificate, we need to like give samples of our device to this. There are separate laboratories which would test for FCC, right? So we would need to give our sample devices to these laboratories, and they would actually test and say if we pass or not, right? And also like this CE certificate. So this is for like European countries, and some regions actually require our device to be lead-free, right? That means we should design a device with lead-free components. So this we should do during the Evt stage. So that's why I said that before we design the product, we need to know about these things before we start designing the product, right? So like after designing the product, if you try to sell your device in a region where this RoHSO lead-free certificate is required, then you would not be able to do that. So you must pay attention for these also, right? So this is regarding FCC. So on FCC also that there are different classes and all. So you need to make sure like on what class your device belongs to, right? So there are different levels for this FCC certifications, right? And so these are like how they would actually test your device, right? So once you have the once you pass FCC, you would get a FCC ID, right? And especially like when you are like building IoT device or devices with RF modules, it's very good if you can select modules which have this FCC ID. So when we call them pre-certified devices. If you have pre-certified devices, it would be very easy to obtain the FCC certificate, right? So that is something you should keep in mind. Right? So like so the other test is like this whole test, right? Here where we test the device to see if we actually test this device by changing different environmental condition and see at what point our device would fail. Like for instance, for example, if I take temperature, we can put the device into a temperature chamber and increase the temperature and see at what temperature the device would fail. So then we know like the absolute maximum value of the temperature our device would work in, right? So like so then after that we have this hash test. So hash test is like like after we know the absolute maximum, then we can, based on that, we can come up with a value to know like what's the operating condition would be onto this device. And so each and every device we would test if that device actually meets this operating condition. So this is a picture of that temperature chamber where we had used our device to test, right? So these are the things I wanted to actually cover during this presentation, right? So we actually went through this product development life cycle. So I wanted to show like how actually we went through this, right? And now I think my colleague Ranjan could walk you through the process where engineers fit into this life cycle, right? Okay, thank you very much. Over to you, Ranjan.
Thank you, Mr. Niroshan, for educating us about product designing process. It was full of wonder. I don't know about you guys, but it really fired me up to looking at those protocols. I mean, I'm actually reading more about EVD on Wikipedia during session. So thank you, sir. Next up, we will be having the Senior Design Engineer of Zone24x7, the resource person of Makespace American Center, founder of Innovator Park, and my children's mentor, Mr. Ranjan Kulathunga. He will be talking about hardware designing consideration in his session. So over to you, sir.
Okay, thank you, Kasun, and good evening all. Shall I share my screen first? Okay. Okay, I hope you guys see my screen, right? Is it?
Yes, sir. We can see it.
Okay, well, so as Niroshan mentioned, so many ideas coming through us, right? So, but some of ideas go to the product. That's a really challenging thing, right? So that means, so even so many university students have their own idea, but they cannot go to the product. So it's a really huge cycle, right? So today I'm going to show you how we can start from the idea to the manufacturer level. So many considerations we have to consider. So with our experience, I'm going to share my experience and uh, so many things with you, right? So today, let's discuss about how to design prototyping and conceptual design, especially in actually my field is ECAD MCAD integration in embedded design engineering. So we have to collaborate these two together to get perfect design, right? Let's talk about what are the PCB consideration in schematic design and layout designing, and after that we can talk about product level consideration as well. And if we have time, let's see how we can do small prototyping using a kind of IoT project. Let me show you how to do that, right? And after that, we can discuss about social innovation, and I hope we can give some career guidelines for to you guys, right? Okay, so as Niroshan mentioned, so actually in Zone 24/7, it's kind of a Silicon Valley based US company. So when we are designing some product, right? So we are designing to export most of the time, right? That means we have to design some kind of a world-class product. Not very simple thing, right? As Niroshan mentioned, we have to get some certificate of them. So we have to do so many things. We have to do so many analytical things, and we have to consider so many design considerations to get the certificate very well, right? So actually, as I mentioned, so not only that, actually I have so many design experience. So while doing the project we can learn, right? So sometimes when you are a fresh graduate, right, so you don't have much more experience about project, right? So while doing a project you have to learn, right? So that is really needed. Do lot of projects, right? So actually we learn lot of things by doing projects, right? So actually, if you can remember, in very first day, Tilina mentioned about the kind of a e-signage, right? That means, can you remember this type of display? Even Ushan also mentioned about supermarkets. We can there is a product we can showcase the discounts and everything using this kind of a device, right? Actually, when I joined with Zone 24/7, this was my first assignment, right? And uh, every one of you guys, I believe, every one of you can uh, write us in simple format to drive this kind of a LCD. Very simple, right? So even if you don't know, you can go to the internet and you can simply download the code and every schematic design and everything, right? But our challenge is, so let me explain about a little bit about this display. Actually, this is a special type display, in type display, right? So the specialty of this display is, even once you update the content, right? So even when you remove the cable, this content will remain, right? Until you update the content next time, right? So that means once you update, it will remain, right? That means it's saving power, right? So Serena well explained about this device in very first day. So that means we can use this display to design some power in power saving devices, right? So the challenge was, so there are some displays, right? So it's kind of a Chinese display, but when we want to write some kind of a firmware into this, there are no data sheets, right? That's the real challenge we have to face, right? So then how we can do this? So the way we did that, actually, we purchased some kind of Amazon Kindle, right? So in there we have this type of display, right? And we tap this one, right? So that means so when we communicate, right? So we don't know how to communicate with this device, right? So we have to find the protocol how to communicate with this device, right? So we have to write our own driver, right? So then using oscilloscope and logic analyzers, we found the way to communicate, right? So it's not a simple process. So we did so many research to find the protocols of this, right? And it's actually kind of a black and white display, but be able to convert into the grayscale level as well, right? Even manufacturers are surprised, right? So that is the way, if you know the fundamentals, actually, you don't want to worry about how to do the project, right? So that means, so in industry, you cannot avoid this project, right? So when you get a new project, somehow you have to do the project, right? So that is the challenge. If you are a real engineer, you have to do this project somehow, right? Otherwise, you will lose the project, right? So remember that. So that means I want to tell you learn fundamentals. That is really important, right? So for example, I will take this example, right? So I'm pretty sure most of you know about how to drive a NPN transistor, right? But I'm pretty sure most of you don't know how to drive a Pnp transistor, right? So let me explain about like this, right? Okay, my requirement is right. So where we have to use NPN and PNP transistor. So this is the requirement, right? So imagine you have a load like this, right? So load can be a motor, whatever electronics device, let's say, right? So if you want to drive this one in negative terminals, if you want to switch this device, imagine this is a 5 volt and this is the ground. This is the load, right? This can be a motor or light or whatever thing, right? So we can switch this, maybe you can switch ground, right? Sometimes you have to switch this device from the power side, right? I think if you can remember in last session, Ushan mentioned if you want to make some energy saving devices, right? So sometimes it can be a amplifier, right? So in your circuit there are so many domains, right? So we have to switch this domain to save the power, right? So in your circuit, right? Then sometimes you have to switch this domain, right? So sometimes a barcode scanner or sometimes a amplifier, USB hub, right? So likewise you have to switch these devices, right? So then you have to learn about the fundamentals, how to switch this, right? So you have two options. You can switch ground connection or positive terminal, right? So the challenge is how we can select find the hardware to drive this, right? So this is the requirement, right? For this case, right, you can use the NPN transistor. For this case, you have to use the Pnp transistor, right? So why? You can see if you want to drive this load using microcontroller, right? So typically microcontrollers are work around 5 volt, right? So imagine that, right? So there are some different logic levels in different platform, but typically it's a 5 volt, right? And using NPN transistor, you can switch on this one, right? So I'm pretty sure from your science knowledge, you know that, right? You can use this transistor to switch on, right? Transistor work as a switch, right? Okay, what is the bare minimum voltage you have to provide to switch on this circuit, right? So imagine this is a silicon type of transistor, right? So I would like to see your answer in chat box. What is the minimum voltage that we have to give to activate this transistor? If you like, you can type, right? Okay, so this is a 0.7, right? So that means if you provide 0.7 to this B to E, this will be turned on, right? So that means this is for the NPN transistor, right? Maybe this load can be a 5 volt, 12 volt, that's okay. You have to give 0.7 voltage to B to E. Then this load will be activated. That means ground pin will switch, right? So that now my case, now we have to turn on PNP transistor, switch this positive terminal, right? You cannot use NPN transistor, right? So you cannot use load to here, right? So that means to E you cannot put the load, right? I mean in NPN transistor, right? For that case you have to use the PNP transistor, right? So I'm talking about this. You have to learn the fundamentals when you do any circuit. Start from the fundamental, then you don't want to worry about, right? So thinking about this PNP transistor, you can use this. I told you NPN transistor we can use to the switch to the ground level pin. PNP transistor we can use to switch the positive terminal, right? Okay, now here, what is the I'm pretty sure most of you don't know how to drive this PNP transistor using microcontroller, let's say, right? Okay, I will explain that one very simply, right? Okay, so imagine you have a microcontroller and you have to switch this load positive terminal, right? So that means you have to provide the 5 volt to this load, right? It can be a motor, whatever thing, right? Okay, we can use the PNP transistor, right? You have to select the current rate and everything when you select the item, but think about this type, right? PNP, right? So what is the bare minimum voltage and where we have to give the bare minimum voltage to this PNP transistor, right? So any volunteer, you can type in the chat box what is the pin we have to give that 0.7 voltage to activate this PNP transistor, B to C or B to E or E to C, right? So I would like to see your answers. You can type, right? Okay, so I will explain it's like this, right? Okay. So this is really interesting, right? So learning electronics must be a very interesting thing if you are a real electronic guy, right? Okay, now this is my transistor, right? PNP transistor, right? So this is E and this is B and this is C, right? So this pin should goes to load and then ground, right? So we are going to provide, now imagine this is a 5 volt, right? Okay, now using resistor you can switch on this device using MCU, right? Okay, now you have to provide 0.7 voltage to B to E, right? So that means you should provide this voltage different, right? So especially B to E voltage different, if it is equal to the 0.7 voltage, this will be turned on, right? So then what will be the bare minimum voltage to provide to this pin, right? So that means you can start from the 5 voltage and you can drop the voltage into 0, right? So at what point will it trigger? So normally I told you here to here it should be a 0.7 voltage, right? So that means when you when it's 5 volt, no voltage different, right? So that means it's turned off, right? So that means no current will go to this circuit, right? Then you can reduce the voltage, and what will be the voltage to saturate this 0.7 voltage? That is 0.3, 4.3, right? So when it's 4.3, this will be turned on, right? So that means using microcontroller you can you don't need to give analog voltage to this one. So normally you can give 5 and ground, right? So if it is a 0 voltage, this will be turned on, right? Earlier what happened? You have to give positive terminal, right? So for the NPN transistor you have to give 0.7 or 0.5 5 volt 5 volt definitely it will work, but minimum voltage is 0.7. Above that it will work, right? That means positive trigger, right? Something like this, right? But here you should give negative terminal. That means when you give ground signal, this NPN transistor will work, right? But if it is only 5 voltage, it will work, right? Why I explain like this? So here 5 volt, here 5 volt, right? So now what is the maximum voltage that you can provide from the microcontroller? That is 5 volt, right? That means you can have a 5 volt here, right? So what will happen if it is a 12 volt? Now there is another challenge, right? You can give maximum voltage is a 5 volt from the microcontroller. Now we have to make voltage different, right? So that means I told you here to here it should be a 0.7 voltage gap, right, to turn on this one, right? So that means at least you have to provide 11.3 voltage to this pin, right? Can we provide using microcontroller? Can we provide 11.3? No, right? So then we have to use another transistor That means we have to use another NPN transistor, and we have to use pull-up arrangement, and this should be a 10K resistor, and this should be a ground, right? So then what will happen? You can switch this NPN transistor using 5 volt pin, GPIO pin. Then you can connect this one to the 12 volt, right? 12 volt. This is NPN transistor, and this is PNP transistor, right? So what will happen now? You can switch this NPN transistor simply using microcontroller, the 5 volt, then it will switch. This is 10K resistor. Then when it's provide 5 voltage, it will switch to the 12 to 0, right? So then you can achieve this point. More than 11.3 you can go, right? So this way you have to think about electronic fundamentals when you design the circuit, right? So remember that. So likewise, when you design electronic circuits, if you know the fundamental, very easily you can design your circuit, right? Okay, so that is additional thing for your knowledge, right? So I'm talking about I'm going to talk about product design flow when we get new project from the client, right? So we have to think about the process as Niroshan mentioned. So when client give a requirement, right? So sometimes we have to ask flexible questions with the client, right? So because sometimes they have real great idea, right? But they cannot express their idea to us, right? So then be able to ask WH questions from them, right? So to get perfect idea from them, we can ask WH questions. Otherwise, sometimes when we start the project, client idea is different. Uh, our management team can understand in different way, analytical and programmers can understand it different way, right? So to overcome that problem, so you can ask WH question from them, then we can get the requirement. Not only the client project, even when you start the project, university students, as a university students, you can ask question from yourself, right? When we start the project, or you can ask get the help from your friend, right? So that is the first thing, get the client requirement perfectly, right? So then you have to collect the relevant information, right? So what are the relevant information, right? So that means when you start new project, right? So you have to find the competitor product in the market, right? So otherwise you will make same product, right? So that will be a competitive thing, right? So then definitely you have to do a market research, right? And you have to find the component, available component, I mean possible component, right? And you have to add the features to your project while discussing with the team. That is really important, right? So that means it's not like a individual project, right? So that means when we are doing a industrial project, we have to deal with the team, right? So that means it's a really interesting thing actually. So not alone you cannot work alone in industry, right? So that means we have to discuss with other people, right? We have to be a flexible person, right? And in the discussion room we have to discuss about so many things, right? So you know about Niroshan, so he is next to me in office. So we have so many arguments when you start projects, right? So that is really needed, right? That should be there when you start the project, right? And if you have to study about the data sheet and technical guidelines and everything, sometimes because when we purchase component, they have some kind of a lifetime, production lifetime, right? So that means within 5 years, production line will be closed, right? So we have to think about those things also when you start the project, right? And once you finalize that stage, we can start the conceptual design, right? Based on the client requirement, right? Even you don't need to have a 3D design like this. You can take a paper and pencil and you can sketch the drawing, right? So that is really needed, because while asking the question, you can design a sketch diagram or 3D design diagram to showcase your idea to a client. That will save thousands of words, right? Then based so not only one design, right? So we can design couple set of designs and with the different features, right? And different UI and UX, we have to think about that, right? So, and we can render those image if you have 3D design software like Maya or SolidWorks or whatever 3D design software, you can design it, and you can ask with the client. Okay, now it can be 2D or 3D though initially, right? But when you go in detail design, you have to definitely go with the 3D design, right? And also, can you remember Niroshan told about kind of a user experience, right? So that is really important. When you design something, we have to think about the color of product and everything, right? So it's another subject actually. It's called, this is in a software industry, but we can apply for this one in hardware as well, because when we design this one, we have to think about the colors and everything. It's called UI, right? User interaction. And UX mean user experience. How it, if you can remember these buttons, right? So sometimes we can place this button in right side or left side, right? It depends on the user, right? So we have to think about where we have to place this button, right? So it's a really interesting thing. By getting client requirement, we have to design the product according to the client requirement. That is really needed, right? And once you select the, so I told you, you can design a couple of rendering images like this, and you can select one out of all design, and after that you can go to the in detail design, right? So that is the first phase about conceptual design, right? That is really needed. Also, sometimes we can insert some kind of because when you show some image like this, you don't know the scale, right? Even if you can add some non object like this, you know, the height of human, then you can have some idea about the height about this project, right? So likewise, there are so many ways to express your idea perfectly to the client, right? Before starting anything, I mean, at this moment you don't think about hardware, what are the hardwares, and I mean hardware level, right? PCBs and not everything, but just go draft the final dream project about using client requirement, right? Okay, so this is the way how we started that NGPV unit, right? So initially we I was there. Initially, we started this project like this, right? So we got the requirement, and initially we started within very couple of hours. We designed and it started like this. After that, there are so many phases going on and so many iterations happened. So it's a really interesting project actually. We know A to Z about this project, right? So that is really a challengeable thing, right? Okay, so when we design this type of thing, right? So I told you, once you design, once you select conceptual design out of all, we have to go to the in detail design, right? So it's a really challengeable thing, right? So let me show you on example, that example, which this is the way how we design about that project, right? So it's not very simple thing to design something like this, right? So we design A to Z this project, right? When you design something like this, we have to think about MCAD ECAD integration, right? ECAD MCAD integration. ECAD mean electronic circuit designing, and MCAD mean mechanical computer design, right? So actually, you have to do both when you design something like this, right? Mechanical engineering and electronic engineering you should learn, especially in mechatronics field. Actually, I'm also coming from mechatronics, so I learn both. That is really advantage for me to design this product, right? That means I can switch to the mechanical design using SolidWorks, and I can switch to the electronic design tool like Altium, because I know the both, right? So that is really important as a design, right? So learn both. That is really important even when we start from the conceptual design, right? So the important thing is, so can you see this? So this blue color area is our PCB area, right? So once you place every component in this design, right? So we have to design our PCB within this area, right? And normally those wire routings are freely come with like this, right? Freely come like this, right? So you have a left speaker, the left speaker connector should be in left side, right? So what will happen if you place a PCB like this and left speaker connector somewhere else this, right? So that is not user friendly design, right? So you should connect left speaker wire to this area, right? So those kind of critical connectors we have to place first, right? So you can use this wiring diagram, right? Freely there are some I will show you. This is really important when you design final design, right? Okay, something like this, right? Very complex thing, but this way wires are come freely, right? So in this area we have to design the PCB, right? So then you have to place the connector to the relevant place, right? So to get that idea, you have to finish mechanical design first. Not first actually, you can synchronize both. So that is really important, right? Then you can design perfect PCB into this area, right? Okay, and now you know about conceptual design, right? So now when we start real hardware, I mean PCB, ECAT, right? We have to do so many things before going to the real PCB design, right? Actually we can prototype PCBs in different ways, right? So wire wrapping, we can use breadboard, we can use Vero board, right? I believe you know about these things, Vero board and breadboard. In breadboard, simply without soldering we can make a quick PCBs without soldering, right? Through hole component we can use. In Vero board we can solder the component underneath of this board. You can solder the component, and it's pretty good than breadboard because it is fixed. Even if it is a robotic project, you cannot sometimes you cannot use breadboard when it's move. There can be a loose connection, right? Anyway, so those kind of a testing you should do before doing PCB, because if you don't have a confidence about your PCB, it will waste your money and the time, everything, right? In PCB design there are two parts: schematic design and layout design, right? Schematic mean you can use symbol to design the circuit, and you have to layout mean you have to follow the real sizes of the fruit pins and everything, and you have to draw real paths to make your perfect PCB, right? And also before that you can do sometimes simulation. So let me show you very interesting simulation software called Proteus, right? So not only this one, you can use any simulation software, but as a university student, I think you guys can use this type of tools to test your concept, right? Okay, this is a Proteus. It looks like a electronic lab, right? So you can do so many things, right? So you can perfectly design your concept idea, and you can write Arduino codes and everything. You can use different type of microcontrollers in this platform, using this platform like Arduino PIC microcontroller, right? So then how we can engage browse the firmware to this one. You can use the Arduino IDE to write the code, and when you double click, you can find the hex code, right? See, hex code. Hex means it's a kind of a machine code. When you write a C code, you can compile into the hex code. You can browse the hex code like this once you compile, right? So then you can browse it, and you can insert that code into this virtual environment, and then you can graph your circuit perfectly, and you can run this, right? See, when you run this one, right, it's running in real time, right? See, you can see the your algorithm work perfect, right? So you can, this is proximity sensor, right? So you cannot touch this sensor, no, it's a virtual environment. you can give some kind of a voltage different to this pin, like it's represent like moving your hand, right? So when you change the voltage, it looks like doing real, right? So then according to that, you can take a decision. You can light up bright lights and anything you can do. So likewise, it looks like this software is a very interesting thing. You have a oscilloscope and multimeters and everything. It looks like electronic virtual lab, right? So this is an interesting thing as a university student. Really good to learn, right? Okay, I'll not go into detail. Try to do yourself, right? And when you design ECAD, whatever embedded system or electronic project, you can use ECAD tools, sometimes free software or licensed software, right? As a beginners, you can use, I highly recommend for the beginners, you can use ECDA. It's an online based tool. Simply you can go to the, actually it's done by JLC PCB, right? So you can log into there and simply online you can design the PCB. There are so many libraries you can find from the cloud, right? And as a free software, I highly recommend KiCad, right? You can design your PCB, even mechanical support. I mean, 3D wise, you can see the PCB as well, right? And also some tools like Eagle or Proteus you can use, but those are not free, right? But if you are plan to go to design professional PCBs, you can go to the Altium or OCAD, also Mentrography, right? I'm using Altium, so Altium and SolidWorks, right? So those are not free, right? So it's really cost. If you are a university student, you can get some education versions, but not free, right? And as a free CAD tool, you can use FreeCAD, right? Or Blender or whatever free CAD tools you can use, right? Actually, it's not depend on the tool, right? So as I mentioned, learn the fundamentals. Even using Photoshop, you can design the simple PCB, right? But you have to give a lot of features when you design very complex circuit. But if you know the fundamentals, right? So tools not be a barrier, right? So if you know the fundamental, you will know how to design the PCB perfectly, right? So tools give very helpful if you select the right tool, right? So that is important. And let me discuss some schematic design consideration and layout, and afterwards let's see product design consideration, right? Okay, now we start from the conceptual design, and we start the fundamentals. That means before starting PCB, you have to uh, do a testing and everything, right? So now we are really going to start the PCB design, right? So I'm not going to show you how to design the PCBs, but when you design, remember these things, right? You should follow these things, because as engineers, when you do something, sometimes if it is a teamwork, in the middle of project, sometimes you have to hand over to another person, right? If it is a teamwork project, especially in industry, right? It's not like a hobby level project. It's very we call you have to you have to be a very responsible person about the project, right? So that means when you share your design with someone else, he should be start from that point, right? So that means you have to have a very well documentation about the project, right? When you start the project, initially you should start using this kind of a block diagram, right? That means using Visio, whatever tool, even Word or whatever thing, you can start to design this kind of a block diagram, right? So the important thing is you can do any changes in this one. Even management team or non-technical person can understand, right? So imagine this one. Actually, this is also too much. So you can um, have block like a MCU. Later you can select the microcontroller, right? So MCU or MPU you can select, right? So at least mention the block wise, right? So USB hub, amplifier, right? So simply mention about the domain, not using manufacturing part number, but select the mention the domain, right? So that is enough at this initial moment. Later you can improve this, right? Then you can ask with the client or hire expert people what are the features of this project, and you can simply understand, right? So later you can start the schematic design, right? So when we start the schematic design, right? So let me show you very interesting project what I have done, right? So when you design something like this, right? So this is our robot PCB. When we start something like this, so you will have so many pages, right? Right, not only one page. See, you have a lot of schematic pages, right? So one page will not enough to do it. So then we can design separately power domain, microcontroller domain, RF domain. Likewise, there are so many domains, right? But in very first page, we can have this type of hierarchical design, right? So if it is a very big project, otherwise, if it is enough to do in one page, we can do it. But in industry, this is the way how we do, right? And when you do something like this, right? So these pages you can mention like this P0, P1, right? So likewise, and you can give a perfect name to refer very easily, right? So follow these fundamentals when you design the PCB, right? And normally when you start the power flow, right? Actually, these are the things that we learn by doing, right? That is why we want to express these things for you, right? So when we design PCBs, as a common sense, design the power flow left to right, right? So we feel that, right? So then also mention the power rating. That means power consumption. So I will discuss about the power budget later. So that will be really important. So this power trace will deliver 2 ampere current, right? So that means when layout designer start to do the layout, he can refer this. This trace will deliver 2 ampere current. Then I have to design that the trace according to that current, right? So likewise, that will be helpful. Right? Also, when you design a big project, right? Some test points should be there. If you want to test it, right? Later, 3.5 volts. Likewise, you can have a test point. Also, if you have so many blocks in the power one page, sometimes you can separate this one to understand very easily. Likewise, this is the microcontroller thing, and this is the programming header, right? So likewise, you can have some dotted box, right, to understand this block, and you can have a name, right? Also, when you design a very big project like this, right? So you can have so many pages. Then how we can connect this page connector to another page, right? Right. So that one we can use some kind of a net naming method, right? If it is a one page, right? So in one page, if you want to connect, so you because otherwise, if it is a complex PCB, it's not. You can draw wires here to here, right? So by crossing all the things, right? Then you will be confused, right? When you do very complex circuit, you should design this type of very simplified method, right? So if it is a one page, right, you can one page mean if you want to connect this trace in this within this page to another connection, you can give a name to this trace, right? So it's called net labeling, right? But sometimes you have to connect this wire to the next page, right? Then we have to use the off page connector, right? So it's like a global and local variable, right? So this is looks like local variable. This is apply only within the page, right? So there should be another name within this page, right? So you can find same name should be there, right? In another pin, right? So this is to connect page to page. This is called off page connector, right? So this is like a global variable, right? So once you give this connection, whole design, right? That means you can access from another page by giving same off page connector name, right? So that is also really important when you design the schematic, right? So follow those things when you design your challenge, right? So we will be evaluate you whether you follow our best practices or not, right? Because you have to do a challenge at the end of the webinar series, right? And also, as I mentioned, you must mention the power requirement. I mean, you can mention about the current rate in these places, right? And also, if you not using any pins, you can mention it's like this, right? Like a not connected, right? So in the tool, there are some symbols you can add to this one that is help to reduce your errors, right? So that means when you check design rule errors or ERC or DRC, then you can minimize the error, right? Okay, another thing, when you design circuits, right? Decoupling capacitors. I think you heard about this, right? Not heard sometimes, but you applied already, right? So for example, 7805 small regulator. So in there you have a kind of a big capacitor and small capacitor, right? So what is the purpose? So actually in capacitor are used to store the energy, right? So by using that theory, we can reduce the noises. I mean voltage fluctuation in the voltage power supplies. We can use this capacitor to remove that fluctuation, right? So even this small capacitor will remove small noises. This will be remove big ripples, and this small capacitors will remove noises, right? So even in your circuit, if you have a motors or kind of a thing, sometimes those type of noises will come to your circuit, right? So then it's kind of a noise, right? Then you can use this type of capacitor to remove those noises. Let me explain again in layout consideration, right? Okay, another thing. So have you feel something like this? So especially in dry days, when you try to touch some metal surface, sometimes a USB port or door mount or some car door or whatever thing, you will get shocked, right? Why? So when we walk freely, especially in dry days, our hands will get what do you call electrically charged, right? That means when we try to touch some metal surface, it will discharge, right? That electrical charge will charge through the ground, through the device, right? What will happen when you design something and when you try to touch this connector, because of our static charge, this can be destroyed, right? To overcome that problem, we can apply some kind of a protection devices to your circuit, right? Especially in your computer near to your USB port, you can find this type of protection device to overcome that ESP charges, right? So this kind of thing you have to add to your circuit as a protection thing. And also fuses you can add to your circuit as a protection item, right? Okay, once you complete your schematic, I'm not going to tell everything, right? So I just got few points about schematic design consideration. There are so many things, right? But just learn about this, right? So when you design your circuits, right? I told you have to calculate the power budget. Each and every component you should calculate the power budget, right? So how we can calculate it? So normally you can go to the data sheet and you can find the power consumption when it's operate in different modes, right? So then if this module will require this let's say 300 milliamperes and this 200 milliamperes, likewise you should calculate all the things, right? Like this, right? See, we have to do this when you do very, I mean, standard projects, right? See, we can mention about the voltage and the power consumption, right? So then at the end, you will see the total power consumption of the device, right? So then according to that, you can select the power supply or battery, right? So likewise, this should be there. As the engineers, when you provide a solution to the client, it should be perfect, not like a trial and error thing. When you provide the solution, it should be perfectly work, right? So that's the meaning of engineering, right? Okay, so not only that, when you select the component, so this is called BOM, bill of material, right? So when you select the component, even when you select the resistor, we have to think about a lot, right? So if it is a very well sensitive device, don't purchase low, I mean low quality device. Go for like a very standard place like DigiQ or whatever thing, right? So we have, because we have to find the data sheet of each and every component, and based on that we have to design, right? Also you can so once you complete your BOM, it looks like this. Simply you can upload into your CSV file to the website service vendors. Then they will send the component to us, right? But these days finding component is pretty difficult because the whole world is going really bad. There is a huge silicon shortage. Then we have to be very carefully when you select the component for the production, right? Okay, now let's little bit talk about layout consideration, right? So because your circuit might be your schematic design may be perfect, right? But when you come into the layout design, sometimes if you don't follow the if it is simple logic level thing, it's okay. But if it is a high speed thing or a special thing, sometimes schematic will be perfect, but if you don't follow the layout consideration, it will not work, right? So that let me discuss few things with you, right? First of all, I told you we have to select the once you design the conceptual design, we can have some idea about the PCB shape and the size of the PCB, right? Because once you design your rough conceptual design with the critical component, you will get some idea. All right, so this will be the PCB size of my product, right? So you don't add all each and every component, but just add the critical mechanical design into the conceptual design and get the idea, right? So then you will understand, this will be the size of my PCB, right? Or sometimes you can export, if it is a complex geometry, you can export that DXF file to your ECAD tool, I mean like Altium, right? So there are some special tools to do that, and it's very easy, right? And if you add 3D design into your CAD tool, ECAD tool, right? So it will save a lot of time, right? You can design perfectly, right? Because otherwise you will design with blind, right? So if you don't have a 3D design, 3D visualization, right? So you are really blind, right? So let me show you. So when you design this PCB, right? Look at this one, right? So if you don't think about this 3D visualization, right? So let me show you. If it is looks like this, right? We turn off this 3D model. It looks like this, right? You are designing with blind, right? So that means you don't know the connector. That means if it is a connector, there can be a plastic casing, right? So you should keep some kind of a tolerance. in between these two connectors, right? So you will only get that idea if you have a 3D design like this, right? So not only this one, right? So sometimes you can add the mating connector into this, right? So what is the advantage? Imagine you can design this PCB and you can in first phase you can solder the component, right? And everything will be perfectly work. And now at the end we try to connect another mating connector to here, right? So then what will happen? So imagine if it is something like this. So your mating connector sometimes very big, right? Mating connector mean another part, right? And in here also now there is a collision, right? So what will happen? You cannot plug the two connector together, right? So then you will be faced very trouble, right? That is why you should think about everything when you design, right? So actually when you design this PCB we consider so many things, right? So this is kind of a 4-layer PCB, right? Top layer, bottom layer, right? So this is the power plane, right? So see, you should do a power budget to get the idea, something like this, right? So otherwise, depending on the power requirement, you have to decide the power trace thickness width, right? So then you can deliver the power to each and every modules once you did the power budget calculation. This is not an easy task, right? So it's very complex, right? But somehow we are able to do that, right? So this is kind of a engineering plus art skill. Actually, this is my hobby, right? So it's become my job, right? So that should be there. When you do a job, you should love your job, right? So likewise, you can design the PCB very good, right? And not also when you design PCB, right? So you can go to the homemade PCB or you can design PCB and you can get the very professional PCBs. In Sri Lanka, unfortunately, there are no manufacturers, PCB manufacturers, right? So you can go for some kind of service like this, right? So in there, when you select the manufacturer, right? So you have to go to the manufacturer capability first, right? They have minimum hole sizes and trace width and everything, right? So we have to consider all these things. Otherwise, when you design a very small trace width, maybe they cannot manufacture it. Then there is a trouble, right? Then how we can learn everything? We cannot remember everything. They will give a file, right? So we can import that file into our ECAD tool, right? So then we can define as a rule, right? If we violate, it will show as an error, right? So then simply we can check all errors and we can correct it, right? And also, I told you we have to think about mechanical design. It's called ECAD MCAD integration. We can switch it between these two softwares always, right? So ECAD MCAD integration. Even when you think about the enclosure, right? So you have to think about the where we have to place the connectors and everything, right? So it's really important and kind of a game. If you know the mechanical and electronic design together, it will save so many times and you can design perfectly. Otherwise, if it is two engineers, you have to synchronize, right? There are some tools to synchronize like that, even SolidWorks and tools like that. But if you know everything, it will save a lot of time, right? Also, another thing, and when you place this type of capacitor, I told you bypass capacitor, right? So that means even when you place the capacitors, right? You should place perfectly, right? So imagine this is the power trace, right? This is the power, and this way it will go to the capacitor and smooth it, and after that you should provide that filtered power line to the IC, right? Otherwise, imagine like this. This is wrong, right? So it will come. I mean, from the bottom side, there. So this is a wire, right? Looks like river, and power come from this, right? And it will quickly go to the IC, right? Now this capacity is useless, right? So that means it's not do their task very well because you don't placed perfectly, right? So that is your failure, right? So that is why you have to think about all placement and things when you do a PCB component placement, right? Actually, I'm not recommend auto routing and auto placement, right? Even this project, I did it manually, right? So by thinking about all the PCB consideration, even when you place the capacitor, bypass capacitor in big microcontrollers like this, right? So you have to place capacitors nearby to the power pin, right? So in this type of microcontroller, there can be a different power, multiple power pins, right? To get more power to this chip. That means when you place a decoupling capacitor, you should place near to the power pin, right? So likewise, we have to think about all the things, right? And also, there are so many things, guys, right? When you do speed, high speed design, right? Or sometimes we have to match the length, right? I will explain, right? Especially in IoT project, I told you have to design the IoT project, right? So in there, you have to use some kind of a Wi-Fi module or whatever module, wireless modules. When you do PCB design, remember this should be there, right? That means in this antenna area, right? Actually, why this PCB trace? This is called PCB trace, a PCB antenna, right? So using PCB trace design like this, right? So that means these 90 edges act as an antenna, right? So that is why we have to avoid 90-degree routing when you do PCB routing, right? So in your PCB trace, if you route like 90-degree angles, those end act as an antenna, right? So we have to avoid that 90-degree routing. So in here, we use that thing as advantage, right? Also here to here, you have to control the impedance, right? Antenna to chip. So this is very critical part, right? So you have to check, maintain this impedance by controlling the trace width and in between top and bottom PCB gap, right? And this area you should avoid, right? You don't, it's not good to place any component in this area, right? You should allocate this area for antenna only, right? Even this copper pole you have to ignore, right? So also, let me show you another thing. So have you ever seen something like this? Have you ever seen in PCBs like this? What is this? Kind of a curly shape? Why? Actually, this is a 6-layer PCB, right? So why is that? Actually, in this design, we have a microcontroller and RAM, right? So in between microcontroller and RAM, we have to communicate with very fast, right? Fast rate. It's kind of a high-speed design, right? So then it looks like this, right? So let me explain. Normally, imagine this is your MCU, right? And this is your RAM, right? RAM. Then imagine if it's have a 8-bit bus protocol, right? So that means you have, if you don't have any component in this area, you can simply route equal length, right? So that means 8 bus line, you can route equal length, right? So then it will communicate perfectly, right? So that means in here to here, no propagation delay, right? So but in here, definitely you will have a component sometimes, right? In the middle of the PCB, or sometimes this pin will come something like this, right? Then this trace width will be different, trace length, right? So then we have trouble, right? So that means this is a very lengthy one and this is short. Sometimes there are so very big length like this, right? So that means different length. That means what will happen when you send something to here, because of this different lengths in here, it will get different signal phase shift, right? That might be an issue when you communicate like in high speed design like microcontroller to RAM. You have to make all these traces equally, right? So then what you should do, you have to find the most highest length, right? And if you have a shortest path, you should make this path equal to this highest length, right? So likewise, each and every path we have to make to the equal length, right? So it's called length tuning, right? So this is what we have done in this project, right? So likewise, there are so many things you have to follow, and there are some impedance matching like USB lines, right? So we have to match the impedance, especially in USB line. There are plus and minus traces. You should equally route like this, right? So you should follow these things when you design layout. Otherwise, a schematic will be perfect, but when you comes to the layout design, because of you not followed best practices, it might be work, but sometimes under some noisy environment it will not work. Even when you try to get a certificate about your project, as Niroshan mentioned, it will fail, right? Likewise, there are so many things. And initially, when you design a layout, you can start from the sketch routing like this to simplify the complexity, right? And after that, you have to calculate the power requirement. Like if it is a 2 ampere current, you have to find the trace width, thickness, and add the copper like this, right? And you have to calculate the trace width. There are some tools to calculate that, right? And once you finish the layout, you have to add the copper port to the ground, attached to the ground. You should attach that copper port to the ground, right? It will reduce EMI and will have a good ground returning path and so many advantages. We added this, right? Otherwise, sometimes you will not add this most of the time. It's good to add this, right? Also, if you have different ground like digital analog ground, you can separate it and you can connect those grounds line using ferrite beads, right? So then digital noises, analog noises will not go to the digital part, right? Likewise, you can follow the best practices. And also, if you design some special circuit like SMPS, definitely you have to follow the recommended guideline like this, right? So it will showcase everything that mean how you should place the component and what are the traces. Even feedback trace, it should be very small one, right? So otherwise, lot of noises induced to this feedback path, right? Likewise, there are so many things to follow, right? And also, when you place the wire, I told you it looks like a river, right? So don't place wire on top of the pad, right? So because in production line, they will add some kind of a liquid lead to this one, right? Then and it will add to the oven, right? So because of this holes, this liquid lead will go through this hole, right? So that means this component will not solder perfect, right? So likewise, there are so many things to consider, right? And as I mentioned, it's good to once you complete your layout, definitely do the mechanical design and put to the mechanical enclosure. You can synchronize both and test everything before send to the manufacturer, right? Take more time and do perfect design. And once you design your layout, you should do annotation. Annotation means each and every component should have a unique number. For resistors starting with R, capacitor C, right? So likewise, there are unique. Each and every component have a unique name, right? It should be there. Check everything to once you find, right? And add all necessary names, right? Like this type of names to give a very user-friendly PCB. You can add all necessary things like we did, right? And the version and connector name, right? So this is the once you design this type of PCB, even look at this, right? So we align this resistor very straightforward, right? So that is should be there, should be neatness when you design PCB. Otherwise, users cannot use your PCB very easily. It should kind of art, right? Art plus engineering. Okay, and Actually, this is called fiducial mark. In assembly line, you should have at least 3 fiducial marks to place your PCB in the production line, right? So I think it's not important for you, right? And so sometimes I told you to get the certificate, we have to follow the best practices, right? So sometimes you can add the stitching via edge of the PCB. It will act as a kind of a protection in the PCB, like a fence, right? In the PCB, it's called stitching wires. We can add those, right? So, and when you think about production level, so we can merge this PCB and we can have a test bench to test the circuit, right? And we can have a test point, right? And we can design stencil in the production line, right? So likewise, there are so many considerations, and we have to avoid the component in the edges, because we have to guide our PCB to the rail, right? So then we have to avoid the component in these edges, right? So in Sri Lanka, there is a company called Tos Lanka. So if you have a great idea, you can go to them, or international assembly, right? Okay. Likewise, we did so many projects in Zone. So it's really good to show these type of things we have done, right? So as a innovators, so if you have a great idea, if you try to design these things by following best practices, don't think about the technical thing. You will timely you will be able to learn, right? So in this PCB, we did the 4-layer PCB, and we follow so many best practices. So likewise, this is the PCB of this product, as Niroshan explained, right? Actually, we passed that EMI test in this PCB. We are the who designed this PCB and from the A to Z, right? For this PCB design, we use different software, right? And okay, and these are the products that we have done while working in industry, right? So you can see this is called that. So have you remember that CC1100 CC110 00 chip? So we use that chip to this design, right? So likewise, so actually in very first design, we are able to solder this component by hand, right? So it's also some kind of a skill. As an engineering student, you should have that skill as well, right? Then only you can be a perfect engineer. And also we can design this PCB conceptual prototyping using 3D printing or CNC, or you can go to the sheet metal operation, right? So likewise, you can design enclosure using this kind of a quick prototyping method, right? Also, once you design your project, you have to protect your product, right? Before sell them, right? That means you have to get the patent. That means IP, you have to protect your IP, right? Intellectual property, right? So then when you apply for patent, there are some patent drawings, right? So think about this whole thing. And also it's really important to add a guideline when you do a product, right? So this type of instructions and a guideline, and how we can mount this one, right? So everything should be there as a perfect design, right? So that's the thing I will need to cover from product designing side, but I need to discuss very interesting things with you, because as this is a IoT challenge, right? Sometimes this will be useful for you, right? So I'm going to do very interesting thing, right? So now, as very first day, if you can remember, Tilina mentioned, you can have a great idea. You can make into the real, right? So now I'm going to showcase this idea very quickly, right? That means I'm going to do some kind of a IoT project, right? So I'm going to show you the concept by proofing, right? Kind of a POC, right? Okay, now time also going fast, but I try to do very quick, right? Okay, for that I need to have a hardware. I will select board called Node MCU, right? So Ushan, I think last session, Ushan mentioned about different hardware, right? Not not only Node MCU, you can go for different platforms like something like this, right? See, I have different board. This is called ESP32, right? ESP32, and this is called ESP32 cam, right? See, in here you can have camera also and Wi-Fi Bluetooth module. This is very interesting thing actually. So you can do so many interesting projects using this ESP cam board, right? But at the moment, I'm going to use this ESP32 chip, right? Okay. Now, what I am going to do is, what I am going to do, I'm going to use mobile phone with the blink app, right? So it's a kind of application, right? It's you can do IoT project very simply, right? So I think some of you know about this app. You can install this app to your mobile phone first, right? And I'm going to use this Node MCU, and I'm going to upload this what do you call a humidity temperature sensor, DHT11 sensor data to the IoT platform, and also I can control this LED. That means I can monitor the sensor value as well as I'm going to control this LED, right? That means bidirectionally I can communicate with this IoT device, right? Okay. Now, first of all, what I need to do. Okay, by the way, this is also another interesting tool called FritSim, right? So you can use this FritSim software to graph your idea. This is not a simulation. You can add component to documentation purpose, right? And here you can design schematic and PCB layout as well. I didn't draw these things perfectly. Here I just want to share the idea, right? So I can create this project using this breadboard, right? So like this way, I can give a power to this one from the Node MCU board. Red will represent 5 volt, and this is brown, right? So once you give a power like this, and I have 2 LEDs, and I can control this LEDs, and I can monitor this sensor value using my mobile phone, right? So first of all, what I need to do is I will turn on share my mobile phone screen first. This is not recorded one. I want to do it live, right? Right. I'm going to use this any days to share my mobile phone, right? So this is my mobile phone screen, right? Right. So you can download this Blink app, right? Actually, I already have a project, so I will delete this one first, right? Delete. Right, because there is a limitation of this Blink app. If you need more widgets, you have to pay for them, right? But you can do a simple project using this software, right? App, right? Right. So first of all, you have to download this Blink app. When you try to download this Blink app, there are 2 versions, right? So new version and old version. I'm using old version, right? So new version a little bit different, right? So this is old version. Once you install this app, you can create a project, right? So you can first give a name to this one. I will give IoT demo, right? So this is really good for beginners, right? So then you can select the hardware, right? I will use Node MCU. There are a lot of platform support for this cloud platform, right? And I will use Node MCU like this, right? And select the method like a Wi-Fi, right? I'm not going to explain about Node MCU because I think you can't mention about this, right? And once you set the parameters like this, right? You have to create this button. Just create the project. That's it, right? That's it. Now you have a create a UI like this, right? See, I just created my app like this, right? So then you can add this widget. You can click this. You can click this. So both, right? Then you will feel it real, right? Okay. Now here you can go to this top corner in middle. You can find some kind of plus mark. I will create this plus mark and add widget. Sorry. Now I need to add the button, one button and two button, and I will add the two. There are so many things, right? So I don't have a time. I just select this gauge and another gauge, right? So now I have two gauges to display the humidity and temperature, right? Right. And you have two buttons. Let's say red and green LED, right? So double click, touch on top of this button, and you can give a name, red LED, right? Then you can select the pin. Click this pin icon and select the digital pin, whatever pin you can select, GPIO pin. I will select D0, and you have to select the button type, push or switch, right? At the moment I will select push type, right? All right. So there are no OK button. You have to go back. Then it will set, right? Another button. I will select it and digital D. Now I will select D1, right? I will give name as a green, right? And for this one, I will select switch type button and go back now, right? So if you click this top icon, your project will run, right? So that means now it's online, right? So it will check whether you have a hardware connected to this device or not, right? So you can see there is a red notification. That means there are no hardware still connected to communicate with device, right? So once you create this one, there is a email should come to your email account, right? So let me check my email. Right, so I got it, right? So this is link, give a authentication token to your project, right? So that means this is a unique authentication token for my project, recently created project, right? IoT demo, right? I just copy this token, and if you don't know anything, you can go to this guideline, right? And especially you have to go to this sketch generator tools, right? So you don't want to write whole code, right? So the interesting thing is everything will be given by them, but you have to do just configure, right? Okay. Now I told you I'm going to upload this humidity sensor, DHT11 sensor. There are so many examples. I will select this DHT11 sensor example, and here you have to paste that authentication token that they send to us, right? So copy this and paste this link sketch generate, right? And these two are for the new Blink app. As I mentioned, there are two versions. I'm using old version. That's why I will ignore this, right? You have to select the Wi-Fi method and the board and just copy this example, right? So in here, once you copy and paste this authentication, it will upload here. And two things you have to give, right? So you have to give your router name and the router password, right? So I'm going to download this code to the node MCU, right? So then it will find the internet router and it will connect automatically. To connect that one, you have to give a router name and the password, right? So you cannot edit here. You have to copy this code and open empty Arduino IDE right? Right. So you can open new Arduino IDE and select all and just play. Right. Right. So now you are ready to program this firmware. But once you purchase new Node MCU, you have to add Node MCU into this Arduino IDE interface. For that case, you have to do small things, right? So first of all, you have to go to the file preference. There are so many tutorials you can find from the web, right? How to do this project. I just want to show how to do this. Right? And here you have to copy this link to download board drivers, right? So how we can find this from internet? You can find this link, right? Just type how to add Node MCU into Arduino IDE. Right? So then you can find this link and just copy and paste here. File preference, paste here. Right. Now you have to go to the tools, board manager. Then you have to find the board. Right. To take small time to update the index. And here you can type ESP 8266, right? ESP 8266. Then you can install the board, right? So once you install, you will have, you can find the board here, right? Modems. Otherwise, you cannot program the board, right? First of all, I will select this small blinking LED example to test my board, right? Blinking LED, right? And to get the confidence that my board is working or not, right? So I will select this Node MCU board. Node MCU and select the port. How to find the port? Now I'm going to connect my board. Right. I will remove this one. Now I'm going to connect my board to the USB. I will connect. Right. So once you connect this one, you can go to the device manager to find the port. So that means communication port is assigned to COM12, right? So now in this example called blink example, right? I will select the port 12, right? So everything is seems like okay. Now I will. I'm pretty sure about this code. Then I will simply download, upload this code to the board. Right. So it's about this. There's internal LED. This LED should blink, right? So this is the way how you can add the Node MCU board to Arduino IDE, right? So it will take some time. Now it's uploading. 25, 30, 31, 50. 100. Now it should be work, right? See, now this LED is blinking, right? So that means now I have a confidence I can program this Node MCU using Arduino IDE. You should do this one first, right? Otherwise, you cannot do any of this project using this code. So after that, if you can remember, still we have that copy paste code here, right? From the blink app, we just copy it and they will give authentication token. And here we have to give our router name and the password, right? I will type it, router name. And the password. Right, done, right? I just type my router name and the password. Right now, I'm going to install this one into my node MCU. Right. Okay. Now I'm going to install this. Download new code to this one. Right. At the same time, check this. Check your app. Right. That means still it is offline. Right. See, there is a red notification here. Right. That means that authentication token is not downloaded to any hardware yet. Right now, I am going to upload it. Look at this red notification. Right now, I will download. First, I have to save it. When I download this code to this module, right? Still red run, right? Then this is a Wi-Fi module, right? So I have a pocket router, right? So I gave a password, this router name and the password to this Wi-Fi module, right? So once it download this program, it will check the router, and if password and authentication token is perfect, it will connect to the internet, right? So when it's connected to the internet, this red notification should disappear, right? So let's see what will happen. Still 84, 92, 100, right? So now it's downloaded, right? So this should be disappeared now. Let's see. See, now you can see IoT demo connected, right? So now this device is online right now, right? Now let me check, right? Now if you want to edit anything, you have to go to the edit mode. Now here you mentioned D0, D1 should connect to the LED, and this one should connect to the what do you call Pvt sensor, right? Actually you have to create your schematic like this, but I will introduce another thing. Actually this is one of my product, right? So this is called quadrant, right? So actually this is also kind of an innovation from my side, right? So actually right now it's currently available in the market as well. I want to design the kind of project to do all new prototyping. I mean, most of beginners, expert, academic people, they want to play with different platforms, right? Arduino, Raspberry Pi, Pick microcontroller, Node MCU, different platforms. They have to do a research, right? So for that case, I introduced an interesting platform. Actually, there are three platforms, right? So all patent pending items as well. So this is called quadrant, right? So I'm going to use this quadrant board to do this demonstration, right? So the interesting thing is, from bottom side, you can connect Arduino boards to this area, Nano, Mega, Uno, Leonardo, anything, right? And here there is a place to connect your Node MCU. I'm going to connect Node MCU to here now, right? And also pick microcontroller or Raspberry Pi connect. Inbuilt Wi-Fi, Bluetooth. There are so many things. You can go to the innovator.lk to find the features, right? Okay, so then once you connect the board, if you look at from the top side, that pin will be exposed to here, right? So this is Node MCU, right? So now I am going to, and you don't need to give any external power to this board. Once you add the Node MCU, whole board will power up from Node MCU. And if you want to do any conceptual design, right? I mean, prototyping project, all sensors are powered, right? I'm going to use this sensor now, right? I will use this D0 pin to connect the LED, right? Using jumper wire, right? So in this resistor, LED, there is a resistor and it is connected to the ground, right? And I will connect this D0 to here and D1 to another LED and D4 pin to the DH11 sensor. And let me show you very quickly how to do that example, right? I'm also going fast. Try to finish it very quickly, right? Okay, now I will connect this board like this. Right? Bottom side, you can connect the board like this, right? So once you connect, whole board will power from the USB port. If you need additional power, you can have a USB or DC pin, right? Okay. Now, right? Actually, I already connected wires, but I will repeat it again, right? So D1 should goes to LED. I will select red LED, and D1 should goes to green LED, right? And D4 pin should goes to DHT11 sensor data pin, right? In that means this sensor, it is already powered, right? So I just use only communication pin. Right? Okay, now let's see the output. Right, I will play the right. So now you can see when I press this button over the internet, right? So this red LED will turn on. See, red, and this is green LED, right? Red and green, right? Still I didn't connect, add the configuration to these two nodes, right? So let me show you it again quickly. Go to that node nodes, and you have to add the configuration pin. Now I need to go to the Arduino program. In here, one thing I forgot to mention. First of all, you have to download the libraries, right? So a couple of libraries, right? So Blink libraries and the DHT11 libraries for this example. Otherwise, it won't work, right? These libraries you have to download, right? DHT11 and Blink library you have to found, right? Fine. And here, if you go to the code, you can see V5. It's a virtual variable, right? And it may represent humidity. V6 represent temperature, right? That means in the code, remember V5 for humidity, right? Now I will add the virtual pin V5 for what? Temperature, temp, right? And I will go back, and this one pin virtual V6 for humidity. Humidity, right? That's it, right? If you play it, you can see the value very easily, right? See, 69 and 23.6. That's my room condition, room temperature, and simultaneously you can control this LED as well. If you want, you can connect into the buzzer to test your pin. I will connect to buzzer, and in here it simply you can test this prototype very easy. Now this is a IoT device, right? Actually, you don't need this board. If you have this one, simply you can create this type of IoT project, right? So there are so many things I don't have time to explain. Even using this one, you can connect with the IEEE platform. Then through the voice, you can connect this thing very easily. Or sometimes when you go with your mobile phone, when you enter your home area using Google GPS trigger, you can turn on these lights, and you can control this button, right? So that means I can control. This is kind of a IoT device now, right? I can control the device as well as I can monitor the device, right? Simply that's the meaning of IoT. You can control the device and you can monitor the device. If you connected both together, that's it. You have done the IoT project, right? So then with that example, I think actually if you want another product, you can go to the innovator.it, do your electronics and robotics IoT project very easily. We have a product, right? Okay, with that, we can wrap up my part. And additionally, I want to give this message a few messages to you, right? So whenever you whenever you want to do a project, sometimes especially university students ask, so can I can you give an idea to my final year project, right? So many students ask that question. Social problem, right? And give a solution to that one, right? So there are so many social problems. As a university student, you must find those problems, right? So as an engineering student, there are so many problems, right? In different fields, agriculture, medicine, or industry, there are so many problems. As a university student, you must give a solution to those projects, right? Be a social innovator. So then you can do so many things. But when you do project, don't apply electronics every time, right? So that is highly recommended, right? So that means if you know Arduino, every time you are going to use Arduino project, right? So think about this project. So it's a small car park. You have to find a empty slot in the car park, right? So then if someone asks to design this type of project, definitely you will add electronic project, right? But this is very simple concept, but it's very fine work, right? So likewise, think about the best way and low cost method, not go to the electronic always. Find the simplest way to do the project. That means solve the problem, right? So act like that, right? And also when I was in university, so these are some kind of a they call career guidance, right? Then actually when I was a university student, I did so many interesting projects, electronic project, robots. I have made so many things, right? Then what I did when I do those type of project, I took photos and I made a small album, right? And I did very interesting thing. So that means using you can have album. Then I did so many projects. Then when I faced for an interview, uh, I went with that album, right? So then when they asked the question, I have so many things to discuss with them, right? So even they didn't ask about my degree and anything. They ask about this project, right? So that is really important to you as well. So this is called kind of a pitch. It's called actually a elevator pitch. So when you do project, try to make a project, try to make photos and make a small document, right? So not only images with some documents or how it's work and small description, that will be really important. Even when you apply for a job, you can add this one as additional attachment. Not for the CV, you can add it as an attachment, right? So those kind of a thing are really valuable. Also now nowadays world going in different ways, right? Not traditional jobs are really demanding. Now there are new fields come to this stage like IoT, big data, data science, machine learning, IoT, robots, VR, AR, 3D printing. Those are the trending topics, right? So now traditional jobs like accounting and some kind of human operations. So those demand will decrease, right? So we have to learn according to the demand, right? So that's why these fields are really important, especially IoT. Try to, when you do project, university project, try to add some component, IoT or machine learning, big data, that will be really valuable to your degree and project as well, right? So with that, I'm going to wrap up my part. Sorry for I add half an hour additionally. So one day you will definitely get the degree, and you will find how to find my career path, right? So then my recommendation is try to find a job where you can do according to your fashion, right? So fashion mean you can remember Tirina mentioned, if you do a project, when you do a project, you don't know how time is going on, right? So that means sometimes you will end up with the early morning, right? So that's called fashion, right? So when you do a project and when you do a job, especially if you can say I love my job, So that is really great, right? So with that message, I'm going to wrap up my session. And if you want to any help from PCB design or any guideline, feel free to contact us, right? So these are my contact numbers. So thank you very much. So that's my thing to share.
Thank you very much, sir, for the amazing knowledge, the incredible demonstrations, and the inspiring experiences you shared with us. Before moving on to the Q&A session, we have a reminder for our participants. Please be sure to fill in the attendance form using the link in the chat box to ensure valuable certificate. Also, I would like to remind you that you can use our Q&A platform Pigeonhole to post your questions there, and we will ask the questions on behalf of you from our guests here today. You will find the link in the chat box below. We'll try our best to answer all of them. But please do know that we have a limited time frame, so we might not be able to entertain all of your questions. But don't worry, we'll try our best. So let's now move on to the Q&A session. So our first question from the audience is, what are the places in Sri Lanka where we can 3D print or laser cut our designs?
Shall I give you an answer?
Yes, sir.
And Niroshan,
yeah, so I think so in Sri Lanka now there are a lot of places where you can like get 3D printing and laser cutting as a service, right? So but I don't think it would be a good idea to like mention them, since this is a public forum, right? So but if you like just search in Google for 3D printing places in Sri Lanka, you will get a lot of options, right? And if still you are not able to like find them, you can like either contact myself or Ranjan. So we can definitely help you to find places where you can like send your 3D design and then get the 3D printed, and they would actually mail you the 3D printed model to you, right? And there are some places where they like when you send a sketch of your design, so they would actually do the 3D modeling and do the printing and send it to you, right? So like if you're unable to find them by yourself, please contact us. So then we'll help you with that.
My answer is also same, Roshan. And also nowadays 3D printers are not very costly, right? So even you can invest some money, nearly 50,000 rupees. You can find a good printer, 50,000.
Thank you so much, sir. We have another question. This question is for Mr. Ranjan. What type of techniques are used to improve the accuracy of a GPS module? Can we get more accurate readings than the marked range in the module?
Actually, there are you can find you can give a requirement when you purchase the module, even use something like DigiKey. And can you recommend any module, Niroshan?
Yeah, actually, so I think they are here asking regarding a specific GPS module. So like without knowing the module, it's very difficult to like answer this question. And also like, so most probably within the module data sheet or reference manual, you would get the details on how to improve this accuracy, right? And also there are some kind of hacking related things which we can do. So these kind of information, normally you could find them in these forums related to the GPS module, or like like for instance, like when we buy some ICs from certain manufacturers, normally they provide a service where we can pose some questions to them and they would answer that. So there are different forums, sometimes managed by those manufacturers itself, or else sometimes there are forums like open electronic forums where you can like post your question there and get the answer. So regarding this specific GPS module, so if you can like send us the details, then we can like check and let you know.
Thank you so much, sir. The next question is, what's the PCB designing software that you are using, and which software that you use to draw the block diagrams?
Yeah, we usually use Altium software and SolidWorks to design enclosures, and also you can use Microsoft Visio, Google Draw it to design block diagram as well. Oh, it's depend on you to find the tool. There are so many tools actually available. And remember, don't use cracked software in industry. As an education purpose, you can use education version. We are not recommend to use cracked software. Right?
Thank you so much, sir. We have another question. What are the available companies to manufacture customized PCBs and models like enclosures in Sri Lanka?
Actually, as Niroshan mentioned, we cannot publicly say about the companies, but we personally know some places. So if you want to do anything, please feel free to contact us. Then we can help for you, right? And in Sri Lanka, there are no PCB manufacturing plants. I mean, PCB manufacturing plants we cannot find, but there are places like the common place in Sri Lanka called Toslanka. If you want to assemble PCB, they will do that job perfectly. It's a Japanese company in POI region. You can go for that.
Thank you very much, sir.
And there are some services which they actually collect your designs, and they would send this design to China or Taiwan and get them manufactured, and then again send the manufactured PCBs for you. So sometimes because they send like bulk designs, so for them it's a little bit cheaper. So you can get your designs done cheaper by using those methods, but sometimes it would cost, it would take some time. So again, like if you need to like do this, please contact us. We can like put you in contact with such services.
Thank you very much, sir. I hope the audience is satisfied with the answer. The next question is for Mr. Niroshan. We can draw mechanical and electrical drawings using separate SolidWorks softwares. Can we do simulation when both are combined? How can we learn it deeply?
Yeah, I think Ranjan would be the best person to answer that, because he's the one related to.
Actually, there are some softwares to synchronize this. So as I mentioned, I'm using Altium software and because SolidWorks software separately, but there are some tools to integrate those two together, like add-ons, or even SolidWorks. They have their own software called Solid PCB. In there, you can switch together, right? So that means when you do PCB design, you can right click and you can switch to the mechanical design very easily, right? So likewise, there are some tools to synchronize two different platforms. And there are some tools like Mentor Graphics and so many tools. It's not like to design small tasks. It's a whole package. Even selecting component and whole project, you can manage using those kind of a tool. It's a package actually, but it really costs.
Thank you very much, sir. Moving on, the next question, what power saving techniques could we apply for modules such as ESP8266 other than using deep sleep mode?
Yes, so like if I answer that question, so if you could recall the device Ranjan had shown, that electronic signage, right? So that design we did taking into consideration the power draw. So we designed that device to like work with 2 AA batteries for about 4 years. So in that design, we actually used these kind of power saving techniques. So other than the deep sleep mode on the microcontroller, so you need to first of all identify which components would be drawing power, right? And so based on that analysis, then you can like design special circuitry to like switch those components, switch them off, right? For instance, like Ranjan mentioned how you can like control circuits using these transistors. Switch on different like PNP and using PNP and NPN transistors, you can cut power. So like if you like before you put the microcontroller to sleep, you could actually switch the power of certain modules, right? And then put the microcontroller to sleep. And when you wake up, you can again use the transistor to switch those modules. So again, switch on again. And also like if you are going for very low power designs, then we would recommend to use FETs instead of transistors, right? So like if you are if your power range is like in nanoampere range, then using FETs would be much beneficial than transistors. And also like you can use so if you cannot completely switch off power to different sections, so there are modules which have these low power modes, so you can use those kind of components also to when you're doing your design. So I hope I answered that question.
Yes, thank you very much, sir. And the next question is, what are the techniques used in 3D printing to achieve a higher industrial quality?
So when you talk about 3D printing, actually there are different types like SLA, it's called stereo lithography. That means the material is like a resin, right? So not a thermoplastic. It's a kind of a resin. So normally that the compare about the quality with fused deposition modeling. That's the most common one. SLA is very high quality one, right? So also once you 3D printer, when you 3D print, actually you can layer height and speed, temperature. You have to control all the parameters. You have to do some test with your printer to find the best quality. Also, you can enable the retraction, right? So likewise, there are so many things. We cannot talk a few minutes, but also once you print, later you can do post processing techniques. That means you can sand it and you can apply some chemicals to smooth it, right? So likewise, there are some techniques called post processing. So anyway, using all this combination, we can get very good 3D print out.
Thank you very much, sir. This was a quite interesting part for me as well. So this is the final question we can ask from our guests today. Using an electronic filter or filtering using a code software is more effective on noise cancelling or reducing?
I think they are asking what is more effective, if it's using the electronic circuit or software to reduce noise. Right? So actually that would depend based on your circuit. So like in some instance, there would be like no other option other than going to a hardware-based noise cancelling filter, because like for the software to work, first of all, your microcontroller or processor which is running the noise cancelling part would need to work very well. So in some instance, you would definitely have to go to hardware noise cancelling features.
Thank you very much, sir. Because of the time limit we have today, I'll have to wrap up the Q&A session now. I take this time to apologize if we missed any of your questions. Thank you everyone for being an active audience and sending us so many questions. This was a very knowledgeable and fascinating session for all the tech enthusiasts gathered here today. Isn't it right, Kasun?
Yes, it is. The session was like information roller coaster. As a mechatronic undergraduate, I find this knowledge holy and godly. I hope you all too had motivation and knowledge from this webinar. Today's workshop wouldn't be this successful if it wasn't our great speakers. So, first of all, I would like to thank Mr. Niroshan Karunaratne on behalf of SLTC and all the participants for teaching us industrial product designing process and devoting your valuable time for this session. Sir, to show our appreciation for the support and dedication you given to make today's session success, the organizing committee of InnovMind would like to issue virtual token of appreciation. And sir, please accept our virtual token of appreciation.
Thank you very much.
Okay. And yes, Mr. Ranjan Kulathunga, I would like to thank you on behalf of SLTC, all the participants for dedication and support you are given us to make this event yet again success. And of course, for teaching us hardware designing and consideration. We would like to issue another token of appreciation for your collaboration for the InnovMind Workshop Series 2. Please accept our gratitude. And there is ongoing competition following our workshop series. Make sure to join us the coming webinars. And the 3rd of October, we have Cloud IoT session conducted by Mr. Prajapriya, the CEO of Principal Architecture of Impact IT Solutions, and who is also Microsoft MVP. Impact IT Solution Gold Microsoft partner, who is Gold sponsor of InnovMind. So stay tuned to learn more about IoT from expert in the industry. And tomorrow we have another session about software architecture on IoT. And guys, we have a request from the organizing committee. Guys, we are going to take group selfie. Can you guys turn your cameras and join with our selfie? Come on, guys, just let's take a quick selfie. Okay, I will count 5 and the organizing committee member will get the photo. Okay, 5, 4, 3, 2, 1. I think our committee get the photo. Okay, and thank you for giving support for this. And now the Santa will give you the details about our competition we will be having the end of our session webinar series.
Yes, Kasun. InnovMind competition will be held following our workshop series. Make sure to join us for the upcoming webinars. We will provide more details on the competition soon. All the latest updates on InnovMind can be found on via social media platforms. Once again, we'd like to remind you to fill the attendance form so you could ensure a valuable certificate for joining our workshop series. Finally, on behalf of IEEE IES Chapter Sri Lanka Technological Campus, I would like to thank all of you for joining with us today. We hope you find this webinar very useful. Thank you very much. Stay home and stay safe. Let's meet again tomorrow. Signing off, I'm Shanta Vijay Singha.
And I'm Cousin Kaushik. Thank you all.